So right now we are just in the designing stage of the submarine. So here's what it looks like so far. So here we have a pop bottle and we have a straw coming into the top. We're going to need to drill a hole in the lid and punch 3 holes in the very bottom of the bottle. Next we're going to attach some weights to the bottom to make sure that these holes are constantly facing the bottom of the tub of water that we're going to be using. So we're going to have a stack of pennies or some weight system that we're going to attach on. Alright, so right now we're going to drill a hole into the top cap of our submarine, and so that way we can actually fit a straw or a hollow tube down into it, so we could be blowing it full of air and causing this thing to resurface. Alright, so here we have our submarine. We still haven't tested it yet for functionality. However, we finished adding the straw, or the tube, so that we can resurface the submarine once it's sunk. And we've added the weight system. So we've added pennies to the bottom with elastics, and we've used the increments of 4, 8, and 12 in this particular order because we think that as the air fills the tube, we don't want the submarine to resurface like this. We want the submarine to be weighted a little more heavily down here so that hopefully the submarine will come up evenly. So the most important part about these particular weights that I forgot to mention earlier is that they have to be on the same side as the holes. That way these holes are constantly pointing towards the bottom of the tub, and the air can actually be trapped by the entire surface. And so once you release the top and let all the air out, the force of the water can actually enter the submarine and cause it to fill up and push all of the remaining air out from this end, causing it to sink. Okay, so this is our first trial. Right now we have our submarine full of air, and what we're going to do is place it on the surface of the water. So I'm going to cap the top, and what's going to happen is the submarine is going to float on the surface of the water. And this is because the air inside the bottle is less dense than the water that it's floating in. So the air inside has nowhere to escape. It can't very well go through the water to escape into the atmosphere. So by releasing my thumb, what's going to happen is the water will replace the air that's inside the bottle, and we've created an avenue for that particular air inside the bottle to escape into the atmosphere. So this is what it looks like. Bam! Okay, so right now our submarine is full of water with a small air bubble on top. However, it's remaining flush to the bottom of the tub. So right now what I'm going to do is replace that water inside of the submarine with air by blowing through the straw, and you should see this submarine resurface. There we go, trial number 1. It works. Alright, so what we have here is our arm capable of lifting a load underwater. So our materials are popsicle sticks, these joints that kind of came with the syringes, and twist ties, and some tape, just like some regular Scotch tape and a plastic spoon, as well as a 10 milliliter syringe, some plastic tubing, and a 5 milliliter syringe. So this syringe, the tubing, and this syringe makes up our hydraulic system. So what happens is we have a 5 milliliter syringe with a certain volume of water being pressed into this 10 milliliter syringe, and what is going to happen is this end is actually going to be pushed outwards. And the principle for that particular phenomena to happen is called hydraulic multiplication, and that is because of static pressure. So static pressure is when you can apply a force through a fluid at rest due to its incompressibility. So you can't compress it, you can't squish it anymore, and so what's going to happen is that's actually going to cause a force to occur in this opposite end. So let's see this little tool at work. So we sunk it underwater, and what's going to happen is I'm just going to push on the end of this syringe, and the arm is going to move. There we go. And then from here, we're going to fill the submarine back up with air, and it's going to cause it to float, and then we can release the object within the spoon. There we go. Okay, so we told you all of the bonuses that has to do with this arm. Now we have to talk about the flaws through prediction. So because this will be all underwater, we're using Scotch tape, and I'm almost certain that this isn't going to hold up and become adhesive anymore underwater. Another flaw that could possibly occur is, well, this spoon might not be able to lift the load, and just this little fulcrum piece probably won't be able to adjust for the weight. So everything's going to be soaked in water. These twist ties might not hold up, so we might have to go with some duct tape. And so you might see a little change in our design while it's being inserted in the water for trial number 2. So, alright, so the theme of our submarine would be to find the ring, the one ring to rule them all. And so we're just going to take this and plop it into our tank. And here is our full culmination of the knowledge of our unit. So here's our submarine, and this will be full trial number 1. Alright, including arm. There we go. So we're hoping that that is going to be able to capture the ring and lift it up, and then we'll blow it up out of the water. Alright, let's do this. Okay. Close. Okay. Oh. Oh, that was close. Nope, that didn't work out. We can't lift it any higher.
Alright.
So this is what this is our best work so far. So clearly, the ring was pretty difficult to take out with the spoon. We had to kind of push it into the corner before we could lift it out. Even though we have it on the end of a spoon, it is too heavy, so it's actually causing the back end to remain in the water. So we're going to have to figure out a way to fix that. Alright, so what we have here is the submarine, totally submerged. It actually has already picked up the ring on the bottom of the basin, and so we're going to lift the ring up, and now we're going to resurface the submarine. Okay, so I'm fairly certain we're going to have to move these weights, the 12 stack of pennies back to the front, and maybe even throw on maybe 24 pennies onto the front, just to balance the weight of the actual arm itself. Let's see, what else?
We can make the corners of the spoon have walls. so the object doesn't fall once we've elevated the submarine.
That's true. Okay. All right. So here is our modified submarine. We've instead replaced the order of the pennies so that the heaviest stack of pennies is closer to the front to balance out the weight of the arm. Also, we've modified the tip of the actual arm. So instead of a spoon, it now is like a toothed hook. So that way it can actually hook into the hole of the ring. We've also prepared another stack of pennies just in case this stack of pennies isn't going to balance out the weight of the arm. So let's give it a shot. All right. So this is now down at the bottom. We're going to maneuver it close to the ring. Oh, careful. It's like a game at Playland. Okay, so now we're going to resurface the submarine. Okay, so that didn't work out very well at all. So we're gonna have to find a way of actually attaching the ring or securing the ring on the end of this arm after we're done collecting it from the bottom, as well as probably add the next stack of pennies to the bottom of this side. Alright, so this is our modified submarine, third modification. So we've added 2 stacks of pennies in the front to balance the weight of the arm, and we've duct taped a small coat hanger to be able to hook onto the ring itself. So the finger projection and spoon cutting didn't work very well, so we went with a little more sturdy of a device such as a coat hanger head, and we bent it so that it'll be easier to scoop up the ring. Okay, so let's get to it. All right. Okay, let's move forward and pick up the ring. Okay, and there we go. Alright, so right now we're going to talk about further modifications that we could do for our submarine. The first thing I want to mention is, while it held the ring, we didn't account for the actual weight distribution after we picked up an extra load. So what happens is it stayed underwater, the ring itself. So we could eventually add an extra little hinged arm of some sort so that we could lift it out of the water, or maybe even move the weight closer to the center of the submarine itself, or add another piece of weight here, perhaps on another hydraulic arm that could slide a certain particular load back and forth along the top of the submarine so that the weight could be evenly distributed to keep the submarine from tilting underwater.
Yeah, also increasing the water level and putting an extra hinge that maybe goes further down or further up so we can scoop the ring completely out of the water to do another useful type of task. But the main goal was accomplished, which was picking something up from the bottom of an ocean and lifting, using fluid dynamics, the ring to a certain height. So that was the main objective, extensions. Yeah, doing some work. So extensions to this is not an A project, but anything extending this would increase their mark. But the objective was this.
So the thing that we've been doing the whole time has been video journaling. So each addition, every modification, and an understanding of all the basic principles and concepts that go into building a submarine and allowing it to do work. So this would be alternative to writing it down in a journal and drawing diagrams.
Right, so we're emphasizing process, trial and error, using the scientific method, improvement on design. We're valuing process instead of just end design look for aesthetics or function, really. So we're just really emphasizing the process and the journaling and the learning that occurs during the building of a device.
Absolutely. And so ideally, the entire class would end up with devices similar to this, but we decided to use a submarine, but other groups would have decided to do arms, but they would have had to come up with their own problems to solve everyday problems with hydraulics and fluid dynamics. So the whole class would come up with a team of projects, and then we would have a questionnaire that was part of day 2 of the culminating activity, and that would be to walk around to 3 different devices that were different than yours and fill out a questionnaire such as how does their device function. There should be 4 components per device, so they have to identify 4 of them, as well as critique the actual performance of the device, and then suggest modifications that they could do to make their device function more efficiently.
Yeah. So that's where the knowledge of fluid mechanics comes into play, not only building it, but also observing a device and critiquing and looking for extensions within the device that someone else built. Also, you'll have to write a 1-page write-up of your own device, stating why you built it, how you built it, what you can do better.